Good morning, everyone. So this is the science video that I promised you. It's about buoyancy. There's going to be 3 different situations. We'll start with the first one. The first situation, normally what I would do is I would do this as a demonstration in front of you, but as that's not possible, we'll have to just do it virtually. So what we have here is a beaker, and it is filled with fresh water. Now it's important that we understand that it's just fresh water, so just water from the tap, for example. And then what we have is a hard-boiled egg. Now the shell has been peeled off it. That's important because if I don't know if you know this, but there's actually an air pocket in the in between the egg and the shell, and that would interfere with this experiment. So the situation number 1 is this. If I were to take this egg and drop it into the water, the fresh water, what would happen to it? Well, and you can try this yourself if you want to, if you have the necessary equipment. But if I were to drop a hard-boiled egg in fresh water, what would happen is the egg would sink down to the bottom. Now, this is an example of negative buoyancy. Okay, this is negative buoyancy. It goes down when the object goes down. When the object of mass in the fluid goes down. So there's a couple questions that I have to ask, that we have to answer here. Why? Why did the egg move down when I let go? I didn't push it. I simply just put it on the surface and let go. And then the egg sank down to the bottom of the beaker. Well, the best wrong answer is that the mass of the egg is bigger, because that's actually not true. The mass of the fresh water is much more than the mass of the egg. But the difference is that the egg is denser, meaning that the particles are more tightly packed inside the egg than they are in the water. And because the particles are denser inside the egg, it's easier for Earth's gravity to pull the egg down first before it pulls on the water. And whatever gets pulled down first goes to the bottom, and the rest goes up top. This is also an example, just not using a liquid. If you were to climb to the roof of the school and drop a bowling ball off the roof onto the ground, it would obviously fall really quickly to the surface of the earth. And the reason is because the bowling ball particles are more tightly packed. They're more denser than the gas surrounding it, than the air surrounding it. So the bigger the differential in density, the quicker the object will fall through the fluid. Situation number 2. Okay, so situation number 2 is similar to situation number 1 in that we have an egg that we're going to drop into a fluid. The difference is we are going to add quite a significant amount of salt to the water. And I don't know if you know this or not, just a little bit of trivia, but salt water is actually a different substance than fresh water. It's completely different. So it's not the same thing at all. Salt water is different from fresh water. And so we're going to pour a significant amount of salt into the fresh water. And when we do so, what we're actually doing is increasing the mass of the fluid, but what we are not doing is increasing the volume of the fluid. And you should have learned that density equals mass over volume. So if I increase the mass but not the volume, then what ends up happening is the fluid in this beaker becomes denser. And if I add enough salt in there, and this is possible, again, you can try it if you want. And this, by the way, is an example of positive buoyancy. If I were to drop that same egg into this fluid, the egg would actually float up on the surface of the fluid. And the reason is because I added the salt into the water, the density of the fluid became denser than the density of the egg. And as such, Earth's gravity is able to grab onto the water and pull it down first before it pulls down on the egg. And as such, the buoyant force of the egg will cause it to float to the top of the fluid, which causes positive buoyancy. So, on to situation number 3. Situation number 3, requires a little bit of patience, but what I did when I do situation number 3 is I end up pouring out some of the salt water, about half the beaker of salt water, and then I put the egg in the salt water. Of course, when I put it in initially, it will float at the surface. But then what I do is I slowly add small amounts of fresh water, and thereby diluting the saltwater fluid. And if I do it enough, what I'm trying to do is I'm trying to make the density of the egg and the density of the salt water, or the diluted salt water, the same. And if I do that, what I end up getting is neutral buoyancy. And that is where the egg is suspended in the middle of the water. It's neither sinking nor is it floating. An example of how this is sometimes used is, this is what, if you ever are scuba diving or something like that, that's the goal, is to achieve neutral buoyancy, so that you can just be suspended in the water. You don't have to, if you want to go up, you kick up. If you want to go down, you kick down. But there's no force that's pulling you down, and there's no force that's pulling you up. And it gives you the feeling of almost like flight. I've only done it once, and I shouldn't have done it because I'm not a licensed scuba diver, but and so don't do it unless you get your license. But neutral buoyancy is something that you want to achieve. We'll be getting into further examples of buoyancy as we go forward.